Hello, my name is Walter Unglaub, and this is how to find the derivative of an inverse at a specific point. So, if we start with the function y as a function of x of 1/8 times x cubed, the first step is to find the inverse of this function, which means we want to solve for an equation of x that is a function of y. So to do that, we multiply both sides by 8. So we get x cubed is equal to 8y. Next, we take the cube root of both sides. So we're going to have x is equal to the cube root of 8y. We don't need a plus or a minus because this is an odd numbered power. And since 8 is actually equal to 2 cubed, the 2 comes out of the cube root. So we have 2 times y raised to the power 1/3. Next, we want to take the derivative of this inverse with respect to y. So I'm going to call my derivative x slash, and that's going to be equal to dx divided dy, or d dy of my inverse function, which is 2y raised to the 1/3 power. So x prime then becomes 2 divided 3 times 1 over y raised to the power 2/3, because we subtract 1 from 1/3, and that gives us negative 2/3, so y appears in the denominator. And finally, now that we have the derivative of the inverse to our original function, we can consider a point. So, if we consider originally the coordinate, or the point, xy, as 2, 1, when we take the inverse, of course, the roles are reversed, so we have y comma x, and the 2 comma 1 becomes a 1 comma 2. So now we can plug in our y value into the derivative of our inverse to calculate what the derivative is of the inverse at this particular point. And that will tell us information about the slope, because the derivative is the slope. So when y is equal to 1, x prime is equal to 2/3 times 1 over 1 raised to 2/3. This is simply equal to 1. Therefore, x prime is equal to 2/3. And that is the slope or derivative of the inverse of this particular function at the point 1, 2, where we have the order y, x. My name is Walter Unglaub, and this is how to find the derivative of an inverse at a specific point.